Okay, so whenever you want to evaluate just ordinary, just a regular functions, like function of x like this, we can write down the functions in terms of vector functions r in order to measure the curvature. Okay, so we have r double prime, we have r prime and r double prime. We can do the same thing as previously mentioned. We can cross these two and finding the value that this is the value. Okay, and then we find the magnitude of r prime. So we already have all to develop our formula here. So we can develop and use it for x. Okay, I hope you get it. So for example, if you want to find the curvature from a simple functions like y equal x squared, just a parabola. Okay, and we want to find the curvature on several points. For example, 0, 0, 1, 1, and 2, 4. We can use this x. Okay, so at x equals 0, x equal 1, x equal 2, we want to make sure that we are going to calculate the curvature. Yeah. What's the question? You want to ask something? Okay. Okay, let me continue this part. Okay, so if you want to find the curvature on each point here, we can do that by take the derivative, okay, and take the second derivative, and then we can input in our curvature here. So this will be the formula. Okay. The next thing is we just input our numbers inside the formula. So the y double prime is just 2, 1 plus 2x, 2x, let's say at x equals 0, so it will be 0. So it's just 2, right? And the next is at x equal 1, so we are going to input 1 plus 1 squared and 3 over 2. It would be 2. To 2, 5. Should be, wait, it should be 2, right? So 5, and at x equal 2, this should be 4, sorry. And 3 over 2. Okay. Now, if you want to be more precise in the graphs, okay, if this is our curve, just a parabola. Wait, wrong. Okay, if this is our parabola y equal x squared, right? And yeah, this is just 0 here. And if this is 2, okay. So from all this, okay, let me compute this for you. So this will be around 0.18, and this will be 0.03 around, okay, around. Okay. So maybe so x equals 0, x equal 1, x equal 2, maybe here. Okay. Okay, because it's symmetrical, it should be the same on left and right. So this is y, this is x. So maybe 0.0 is around here, and 0.1 is maybe here. Okay. Now let's make okay, maybe like that. Okay. Yeah, something like that. So if you look here, okay, if you look this gradient change here, okay, the gradient is changing from this part here, and then going 0, and then going to be positive, right? So from negative to positive. Of course, at 0, as we know, the gradient start to change, right? So if it's across 0 here, it will change from negative to positive, which is in terms of curvature. So this is the curvature graphs. The green one is the curvature graphs. We will see the change of the curvature after we are seeing the curvature on x equals 0 here is the highest, right? It's the highest. The highest because at x equals 0, the gradient is rapidly changes, okay, from negative to positive, right? After they across this 0. And if you look at after 2 or before 2 here, they are gradually lower because the change in here, it's not really that much, right? It's just going here, right? So the change is slow, really slow. This is also slow. The change is slow. Okay, I hope you get it. What the curvature means from this simple curve, well, parabola. Okay. Okay. The next thing is, but let me finish some parts on chapter 13, and we can discuss about our course. Okay. Okay. Any questions? Okay. If you want to ask anything, you can type in your chat box. Okay. The next thing is we have. It's called the normal and binormal vectors. Okay, if you remember the unit tangent vector, we have unit tangent vector. T capital. This is R prime, and divided by the magnitude, right? This is its point, or the direction. It's point in direction of increasing parameter. What does it mean? So if this is your curve, this is the unit tangent vector, right? So if this is the curve, the arrow is going that way. The increasing parameter will be in this way. So the unit tangent vector will be following the increasing parameter. Okay. Okay. That's just what we already learned, right? Okay, now we have a unit normal vector. We call this in terms of n, as in normal, right? The definitions is it's actually t prime divided by its magnitude of t prime. Or if this is with parameter t, let me add parameter t. Okay. The definitions here is the points, the pointing, it's point inward, okay, towards the concave part of the curve C. Okay, so what does it mean? So if we have like this, so let's say this is the curve C, okay, and if this is T, the normal is actually the one that has orthogonal with T. So if this is T, so this will be the normal. And it's pointing, this is the concave part, right? It has like that, right? That's why it's pointing inward of that concave part. Okay? And it's always like that. So this T is also orthogonal with N. Okay, so that's the definition of normal vector. Okay. Okay. The next thing is binormal. Binormal vectors. Okay. By definitions, this means is having cross. Okay, so the definitions is it's orthogonal to T and N. So if you have so if you have this curve here, okay, so this is the arrow like that, so curve C. So you have probably the T is here, and then maybe the N is there. Okay, so T cross N So it will be here, B. Okay. Okay, that's the definitions of the binormal factors. So we can also write this in terms of R prime, divide R prime, cross. This becomes R double prime, right? And R double prime. We can also write that. Okay. Now some definitions also that I need to tell you is the plane. Okay. Let me write this. Okay. The plane that is in parallel with this n, okay, okay, it's called the normal plane. Okay, so this is the normal plane. Okay. So, or maybe I'm writing, so normal plane, the plane determined by normal and binormal factors at some point. We call this point P. Okay, at point P on curve C is called normal plane. Okay. Okay, that's the first one. Okay, the other plane is normal and T. So let me write in different color, green. Maybe okay. Okay, this plane is called oscillating plane. So the plane determined by T and N. Let's say that. Okay. The rest is the same as the normal plane. So yeah. So we can also say that because of the nature of the wait for a minute. Sorry. Okay. So we can also write the oscillating plane is also the closest that uh, the closest to the curve, okay, or to the part of curve C, okay? Or it's containing the curve itself, okay. If you see here, it's containing the curve itself. See here, okay, rather than the normal one, okay. So that's the normal plane and the oscillating plane. So whenever you need to find a normal plane or oscillating plane, this is the way you are going to do. So how to find the plane? We are going to use the equation of the plane on chapter 12. I hope you still remember that. Okay. So you need to review the, the equations of plane on chapter 12. So for example, to find normal plane, what you need to do is finding this finding normal and then binormal, and you get the factor, right? And then you put on the equations of the plane. Equations may be x minus something, a plus b. It depends on the point, which point you want to approach and equal 0. Okay, that's how you're going to find the plane. Okay, and this is also the same oscillating plane, finding the factors and then finding the uh, equation of the plane. Okay. Okay. Uh, Let me write summary. Some of the formula that we have. Okay. So you have first is unit tangent vector. And you have the normal vector. And you have binormal. And you have the curvature, right? Okay. And we can uh, arrange into different set of formula for curvature. at least this is most of the formula, or maybe add one more. Okay, that's most of the formula that we have learned. Okay, so unit tangent vector, normal vector, binormal, and the curvature. Okay. Actually, there's one more. Let me maybe finishing the one more left. Okay. So this is summary up until here, and let me add another one called the torsion. Okay, if we are going to look at the graphs, let's say this is our curve. And let's say this is the T. This is N, and this is B. Let's say B there. Okay. And as usual, you have the normal and oscillating. So this is the oscillating. And you have the normal. Okay. And at this vector B there, if we have this vector, and if we have this vector, we call this is dt over ds. ds means the length of the curve. Okay. And this part is then we call dB over ds, right? And the definition of the torsions is torsion of a curve. The torsions, this symbols, the tau symbol, is negative dB over ds dot n. Okay, I hope you get it why it's negative. So if we are taking the negative part here, right? This is the negative dB over ds. And if we are looking at the diagram formula, so this is the n, and this is the so it's the torsions, right? Okay. We can also write the chain rule to make the calculations simplify. And then we have and later this will be B prime. So the torsions become negative V prime T dot N divided by the R prime T magnitude. Okay. And if we are going to change all Bn into R, we can do that also. So the torsions become okay. Yeah. So we have the third derivative of R because of B prime, right? And we have all this. Okay. So up until torsion, we finish our chapter 13. Okay. So I hope you get the idea for the torsion here. Okay. So actually what a torsion feels or how it looks like, if you are focusing on point P, okay, point P here. So the torsion here, the torsion, what about the torsion there? So we are looking at this point P on how twist the curve at this point will be. That's the torsions. If the torsions is positive, if torsion is positive, then the curve twists out of the oscillating plane. This is oscillating plane, right? It twists out the oscillating plane in the directions of P. Okay. And if the torsions is negative, the direction will be here. So the curve will twist in the opposite direction. Okay, now what else? I think all the chapter 13 are finished. So let me discuss with you about our courses, because from now on until the end of the semester, we will have all will be online. I'm not sure whether in the final terms we still online or just finishing just all distance will be online or not. But I think the last message that the university sent is up until the end of the semester, we will be going online, right? So there will be a problem, right? Regarding to that. First, let me write in green or blue. So first, so problem with distance learning. Number one, how we are going to do exam, right? Especially calculus, because you need to write the calculations, blah blah blah. And the next one is I'm not a teacher or professor, not really sure. The students pay attention or not, right? Like today, I'm not sure whether you are looking at the smartphone or you're looking at the laptop, or maybe going somewhere and just leave your phone, because I think we already did it online like a few weeks ago. When I end the call, some of the students still there, and they didn't really pay attention that the class is over, right? So I'm not sure whether you are really pay attention or not, because I cannot see like all of you. So first, the exam problem, how we are going to do exam. And third, when exam, how we are going to proctor it. I'm not sure you have heard this word before, but what does it mean is usually you need watcher, right, in the class to watch you over during the exam. But how we are going to do that? Because I'm not there at your room, right? I cannot see your work. I cannot see how you are going to finish your work. Okay, so here's the deal. Okay, so my solutions. My solutions. I'm going to create a classroom using Google. And I will put it's actually like a Moodle, but it's more, how to say that? It's more embedded to the Google systems. Like we have the Google Meet, we have probably the exam will be on Google also. So I will make a Google Classroom. I will announce through Moodle. Wait, the announcement on Moodle. And probably how we are going to do the exam is using Google. But of course, I will add some proctor. So from now on, I want you to prepare whenever we have quiz or exam. It can be done by two ways, okay? The first is you need to prepare your smartphone or the laptop, okay? This is as your main device to do exam. So your device on exam is only smartphone and laptop, okay? And you need to face the camera or webcam. Okay, at least here's the deal. Okay, so let me draw. So if this is your laptop here, okay, and maybe this is the camera is here, your webcam, right? And this is you. So you need to be full face in front of the webcam. And this is you doing your exam. Maybe you can write, like you have paper here, you can write blah blah blah. Okay, and before we are start the exam, we need to make sure that you don't have any notes around you. So before we start, you need to tell the if not me, then the TA, how your room will be, and there should not be noise. Please don't be noisy in your room. So don't make loud noise. Okay. If it is on your smartphone, then you need to just adjust your smartphone so that it is seeing your face all the time. It's okay if you're like maybe looking down and because you want to write some calculations, right? It's okay if you're looking like that. But the point is you need to make your smartphone or laptop, the webcam should be on your face. Okay. I will announce later more details about this. Okay. Because why I need the webcam? Because I have the software that installed in the Google form that will detect your face, detect your noise, detect whenever you open another app or tab in your laptop. So you won't be able to search on Google or anything if you want to find like solutions for your answers. It will detect and it will grade your trust. So it will grade your trust. Okay. The trust score, I hope you don't get below 40. If below 40, I will deduct or I will evaluate the total score. And maybe if it's below 10 or 20, I'm sorry, I will give you 0. Okay? The score is 0. Unless you have a good reason for getting this score. So how this trust score will be evaluated? First, you will be randomly taking picture by the software. Okay, and it will be so your face, maybe this face only showing this your hair. Okay, this is low. The trust score is low. So if you have full face, that will be better. The trust score is high. So if you keep getting low score on this face detections, the trust score is getting lower and lower and lower. And if you have like noises, maybe you are talking with your friends or maybe there's somebody in your room, you need to be able to make sure that there is no noises in the room, because noises will also affecting the trust score. Okay, and if you open any tab or any apps or any applications besides your Google Forms, the software will notice, and it will also affecting your trust score. I hope you understand this. I don't want to repeat. Okay, I don't want to repeat. Okay, I will just make some announcement later, more technical details. But I hope you get my point. Okay, I hope you get my point. And all the exam will be going for online. Okay. This is unless we have sometimes in the future we have offline class, if we have. Okay, if no, then this is the way we are going to do. Okay, so all the details is probably like this. Okay, so you need to be prepared. Okay, you are using smartphone or laptop, it's up to you. Okay, it's up to you which one you are going to use. Okay, but before all of this, preparation, how to prepare all the things here. The preparations, you need to be online at least 15 minutes before exam begin. And I will have some discussion on Google Meet, and I will share the link through that Google Meet. Okay. Okay, if there's no question, is there any questions about how we are going to work out the distance learning? Okay, if there's no problem, okay, I don't want you, like, after I explain all of this and I explain later on Moodle, you still don't understand on how we are going to do. And you still ask, teacher, professor, why blah, 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 blah. If you don't read, I cannot help you, okay? Okay, and later technical, I will explain later. Like maybe you have technicals in the laptop or smartphone, etc. That will be another things that that will be explained later. Okay. But before this, I will have dummy questions to check. Okay. Maybe next Wednesday I will check and try to do in maybe 5 to 10 minutes. Okay. This is just dummy, so this is just to test the software. Okay. Oh yeah, what chapter will be in our next quiz? The next chapter, let me write here. The quiz, next quiz is chapter 12 and chapter 13. Okay. Because these two is basically similar. Okay. Chapter 13, you need some part from chapter 12 to explain some things in chapter 13. Okay. So yeah, we will have these two both. Okay, if there's no questions, any questions from anything from chapter 13 or from what we are going to do next for distance learning? Who raised hand? William? Yeah, can you open your mic? Practice exam for, you mean for the quiz?
Yeah, I was just wondering if we could have a practice.
Yeah. We will have practice exam for the quiz.
Because there's some of us that live in a dorm and maybe, I don't know, it could be misinterpreted or,
Yeah.
and
Okay.
like show us um, our test scores so we know what to do and what not to do and how sensitive it is.
Yeah, we will have practice exam, and also because I mentioned that I will open the Google Classroom. So through that classroom, I will probably announce, or you can submit through that Google Classroom, because I think that will be easier rather than the Moodle. Sometimes the Moodle has limitations on the files. Okay, so I will do that the practice, and also maybe giving you some exercise to check whether you are understand or not. Okay.
Okay, thank you.
Okay. So probably, okay. So probably for the quiz, it will be around. Let me check my calendar. So it will be probably around 26. So it's probably May 26. So probably next Monday we will have some practice, and this week I will give you some maybe exercise to check it at your home, and also your TA should be also he should be also giving you exercise. Okay, but maybe my exercise is more about the concept, and maybe for TA it's more about having difficult problems to be solved. Okay. Okay, so probably this May 26th. If there is change, I will announce later. And I need to check also the dummy questions to check how you are going to open the software. Not software, just open the forms, but it is being added by the add-ons for proctored, or for to watch your exam. Okay, so that's the thing I need to discuss with you guys. Okay. Okay, I will give you another informations about all of this later in Moodle in more detail. But for now, I need to continue a little bit, just an intro for the next chapter, chapter 14. Okay, I hope you don't mind, but it's not really that deep. It's only for introductions. So chapter 14, it's called the partial derivative. So partial derivative, so far we have deal in calculus 1. It's called the single variable calculus, right? And in calculus 2, we are now in multivariable. Multivariable means in calculus 1, we have this, right? In calculus 2, this is single. This is multivariable. So we have z. Usually we write z and then f, x, y. So we have at least more than one. Okay. So first, as introductions, let me explain functions of two variables. If we are going to write this in terms of 3-dimension space, let's say it has a solids like that. Let's say this is the xy plane, and we have z as the height, okay, the level. Okay. Or if I want to make 2D projection, for example, if yeah, this is just a actually it's a little bit random, but I hope you get what I mean. So this plane is going to be here, and this is y and x. Yeah, it's a little bit different, but I hope you get what I mean. Okay. So if this is going to be z here, then if we have point of xy here, then this is fxy. If we have AB here, this is FAB. And this is maybe 0. So maybe it's okay. So what this plane means is if we have any point on this xy plane, and we have a solid structure like this one, like this the green color here. If we cut into plane, xy plane, we have projections here, 2D projections. The point is inside of these two variables will determine the level, okay, the height. So this is the height or height. So the functions of two variables is a rule that assigns to each ordered pair of real numbers, in this case x, y, in a set determinant, a unique real number denoted by fxy. And domain range will be okay. So we will have the domain xy on, and the range will be the functions of xy. And we usually write this terms f in terms of z. and this will be independent variables, right? And this will be dependent. So the level of z, or the height, will be depends on x and y. And the other thing that important is in our introductions is the level curves. So if you are maybe remember in your high school about the maybe the maps, like the contour maps, like you have and you have like this, and this one will be darker, and this is the height is higher, right? It's will be dark, or maybe it should be lighter, right? Lighter, yeah. So level curve definitions is, so level curves of functions of x, y are the curves with equation equal k, where k is a constant in range of f. Okay. We can also assign functions of 3 or more variables. So we can assign x, y, z, or maybe more. Okay. Maybe t equal f, and so on and so forth. Okay. Okay, let me check the. Let me check the graphs. Okay, I think I got it. Wait. Okay. Let me stop this and listen. I hope you can see the. This is from the GeoGebra. You can also check and try to navigate the GeoGebra. Okay. So this is the contour plot from the functions z equal functions of x and y. So you see here, it, in this curve here, you will see there are changes in the height, right? So sometimes it's going up, sometimes it's going down, and it creating a parabolic structures all the way around. Okay. So if we look from the top, this is what the contour means. Okay. You will see some parts is darker, some parts is lighter, right? So the one in dark is actually the one that is go beyond that part, or go down, right? So here, if we look here, okay, and it say that it has a test point here, so maybe we can play around. We can move the z test point, so it will move along the contour. So if we are going to take this into the highest contour, it will be in pink color, right? If you take it down, maybe through here, it will be darker. Okay, so it's kind of easy way to see how we are going to check the test point. Okay, let me check another one that has. Oh, maybe this one is a bit better. Yeah, this is the contour. Okay, you look at this, the darker one. The darker one is the one that is going here, right? Okay, it's the beyond the 0, right? So if we are going to, oh, it has all the parameter. Yeah, this is the functions. It's quite complicated. So this is how we are going to. So we can put in all terms here. So this is xy plane. So if we put xy plane, let's put in the here in the darker one. It will be there, right? This is the R point here. if we put, maybe put the this will be the highest one here. Okay, so have you get the idea? So we change the XY positions coordinate. We will have different height, different Z level. Well, it's already having the field of the slope in each of the contour. This is the level curve. So which means this is the how to say, the extreme slope, the one which has a circle. We will learn more about this later. Okay, I think that's enough for visualizations. Let me stop presenting. Okay, present window. Okay, I hope from the GeoGebra you can check by yourself to see the visuals of the curve. Okay, for the functions of two variables or more variables, and to see also the level curves. Okay, now let me go through into the other part of the introductions. It is actually limits and continuity. This is 14.2. So limits and continuity. Mm, okay, let me give you another example. Okay, in 2 dimensions, what we have learned is if we have a curve functions of x, we have maybe point here, and in limit we evaluate from the left and also from the right. Okay, so for example, limit of x as x approaching x0 from the right of the functions should be equal if we approach from the left. And if the limit exists, we can say that it is equal some value L. So this provides the limit exists. Okay, now if we are going to look at the 3 dimensions, so in 2 dimensions we have just x, right? Because we are only observing functions of x. If we have in 3 dimensions, we have x and y. And let's say we have this point here. And let me just draw a random plane and let me mark this as the functions of 2 variables x, y. So we can write the limit of this curve or this plane. Now we are using terms x, y approaching. Okay, approaching x0 and y0. of the functions x, y. Now, if we look at here, there are many ways. So there are many curves that approach So if we look at these functions here, there are many ways to approach. We can approach from here, we can from here, right? There are infinitely many ways, many curves. Now, if we look at the example, okay, on how we are going to observe. Let's say we have functions x and y. Let's say this is our functions. If we are using limit as it is approaching to 1 of xy, then this will be, we are just exchanging our number to our equations. So this will be -2, 1, and then 2 squared plus 1 squared, right? Or we can just evaluate and becomes -2/5. Of course, this is not difficult. But let's see our same equations, and the limit is changed to 0, 0. Okay. Now, if we are taking all the 0 into our equations here, how we are going to solve this. Now we are going to solve each by cases, per cases. Okay. So first, okay, we are limiting along only x-axis. This is when y equals 0, right? You get it? Okay, so before we're going through, if we put here, it will be 0/0. We don't want that, right? And limit. So first, we divide into some parts. So first, we limit along only the x-axis. So this will be, we still write the same limit notations. But here we are only focused on when y is equal 0. So when y equals 0, this will be 0. X is just a constant x, okay? So it's a constant x squared plus 0, right? Okay. And now, because x here is a constant x, so this will be 0. Okay. And the second, limit along y-axis. So this will be at x equals 0. And here is the same as before, but we are limiting only when x is 0. So it's 0, but here is 0 plus y squared. And of course, because we are now imagine the y is constant, then it will be 0. Okay. And the next thing is we limit along y equal x. Okay. So if you look at the here, because we have many curves that can approach this point, we can approach when limiting along the x, along this x-axis here. That means we are equating the y equals 0, or we can limiting this y-axis when x is 0. Okay, approaching this. This is the one that we want to approach. Okay. And then the last part is we limiting the y equal x. And we going here, right? Okay, hope you get my point here. So the last part here, we try our best to limit y equal x. And now, because y equal x, I will replace y with x. Okay. And now we have only x. So x is 0. But this is the same variable. So we have negative half. So it's not 0. Okay. So this and this, okay, it's 0. It's 0, right? It's okay. Our observation is good, right? But here it's not equal 0. So what is our conclusions? If we get different results like this, maybe limit doesn't exist. Okay. Okay, because if you want to provide the limit exists, all the terms that you are going to observe, they need to be all the same. Okay. Now the last part of our course, let me define what we'll do. Okay. So definitions. Let functions be functions of two variables. Assume f is defined in all points on some we call open disk. Okay, I will tell you later. Centered at a point of, let's say, x0, y0. So the point disk, or the open disk, is, so if this is your plane, your f, okay, open this is maybe here. So what does it mean is actually it want to tell you that all this point here, it can be projected into this open disk. Okay. Maybe it's not big enough. Let me make it bigger. Yeah. So all the thing here is actually can be projected into this open disk. Okay. And then we can take a limit of xy into some x0, y0 of the functions itself. It should be equal to some L. And then if for every number epsilon greater 0, we find a delta greater 0 such that the functions minus the value of L is always less than epsilon. When distance between xy and x0, y0 satisfies Okay, so remember the epsilon delta in calculus 1. So in calculus 1, you have epsilon delta definitions, right? In which you have curve and you have the, let's say this is x0. You have the delta and the epsilon. So this will be the delta, the gap delta. So this epsilon minus delta, x0 plus delta. And you have epsilon here. Okay. Okay, I hope you still remember all of this. So epsilon and delta is a notions that it's a really small part of numbers that when you using that to find for every number epsilon greater 0, we are going to find another delta. And the distance between these functions and L will always less than epsilon, which means this is to say that we are going to have, like for example, let's say this. Okay, we have this. This is really small, right? But in terms of limit, we can say the distance is really small. So we can neglect, right? So limit 0.0000002, we can say this is going to be 0, right? So that is what it means for the epsilon and delta. And from what we have done on the left here, we can also make some conclusions and some theorem. So if functions as xy going to approach this some number, then as xy going to I'm rewriting this all over again, along any smooth curve C, if limit if this doesn't exist on C, or if fxy has different value along different C, then the limit doesn't exist. So first, look at here. So first, if the limit of the functions doesn't exist, okay, or if the functions has different value along different curve, this is what we have done here. It has different value, okay. So we say the limit probably doesn't exist. We can say the different values L1 is maybe it's not the same as L2. Or we can also say if xy going to L1 as xy going to AB along C1, and if fxy going to be L2 as xy going to AB along C2, and L1 is not equal L2, then limit as xy AB of the functions, the limit doesn't exist. Okay. Okay, any questions? Okay, if no questions, I will stop until here, and please wait for all my announcement, okay, on about all the details. Maybe we will have for this Wednesday, we will just having a test, not the exam, but I mean testing the forms that I will gonna use. Okay, so I hope you can prepare the either you can choose either the smartphone or laptop, but for smartphone, because for exam you need at least 1 to 2 hours, right, or maybe 3 hours. You need to prepare the battery for your smartphone. My suggestion is using the laptop. I think that will be better. But if your smartphone is enough, then you can use it. Okay, I think I will finish here if there is no questions. Okay, you can leave the meeting room if you want.